Everyone. So in this video, we will discuss about the pipeline run that was initiated in previous video related to the merge request and all. So what exactly these particular pipeline run are there, like what these tasks are actually doing in the backend. So we will discuss about this in this particular video. So like the same thing is covered in this reference guide as well, like whatever task runs are there for that pipeline, like init, clone repository, and everything. So if we start with the init init task run, so basically init task run is just doing sanity checks like for the inputs before anything expensive that will be running afterwards. So it validates for parameters, confirms required secret credential exist or not, checks whether the pipeline run should even proceed, like if any skip build annotations are there. So it's like it is meant to be there so that like if any failure is there, so it will occur in the starting itself instead of running the pipeline along the way. So basic prerequisites are taken care by the init. And then comes the clone repository. So it's just performing the standard git clone for the source repository that we provided in component YAML. And it clones that particular git repo in a shared persistent volume claim workspace. So workspace is just a concept of Tekton. And so, yeah, so the code gets cloned into a shared PVC. And then comes the prefetch dependency. So this is where like Konflux build story comes. So it prefetches all the language dependencies, we can say, like Go modules, pip packages, npm packages, and much more into a local cache before the build actually starts. So the actual container build, step, which is like the build container, can run without any network access and all. So this is the core supply chain security, we can say. So it means nothing can be silently pulled in the build container step during the build, and everything used is recorded basically. And then comes the build container part. So it runs the buildah actually, which build the OCI image from your Docker file or container file as per your GitHub repo, and using only the prefetched dependencies, and no other dependencies will be pulled here basically. And then it produces a image digest result. So those things are then useful further. And so yeah, after the build container, the build image index comes into the picture. So it basically builds a multi-arc manifest, we can see, like image index. So you might have observed, so regardless of any of the architecture of your local machine, whether it can be a ARM-based architecture or maybe S390X or maybe x86-64, whenever you run Docker pull or Podman pull for any image, it automatically identifies which architecture type image it needs to be pulled. So it's all due to this build image index. So yeah, so it is used to resolve to the right architecture automatically. So let's say, but in this particular pipeline, let's say if we have built the image for a specific architecture, then also this build image index, it normalizes it automatically. And then these are the parallel tasks. So because all earlier tasks were like in a serial manner, after one another was running, but all these remaining total 6 tasks are running in parallel. So like first of all, the deprecated base image check, it wants whether your base image used to build the container image is end of life cycle or maybe deprecated or not, because it won't be receiving any security patches in future. And then the scan part, so it basically performs a signature based malware or virus scan for your image contents. Then the shell check, so it performs static analysis on shell scripts for like shell check, and it basically catches the bugs or injection risk. And then comes the SAST Unicode check. So it detects any Trojan source attacks or there or not, like maybe invisible or bidirectional Unicode characters that can look like very similar, but those can perform different tasks. And when those execute, then certain security issue will be there. Then comes the RPM signature scan. So it validates any RPM packages in the image which are signed by trusted keys or not. So to maintain the supply chain integrity. And then the TPS scan. So it is just like trustification analysis, we can say. So SBOM generation occurs here. So which is like software build of material, we can say, which basically contains what things were actually used and what steps were actually done to build this container image, like what exact tasks were there in the pipeline run. So everything. So SBM generation, validation, and likely feeding into dependencies, we can say, vulnerability tracking. So all those things are there. So yeah, so that's why if we see this particular image registry where the image was pushed, we can see this SBOM is there, and we will see how we can uh, utilize it. And in the reference guide, a few other things are also there after TPS scan, like Tekton Chains, so which signs the image and generates LSSA. So we will discuss this in the later part of videos where we will cover the enterprise contract and all those things in detailed manner. So in the same reference guide, we will just check the logs and all for the pipeline run and all. So we executed this command earlier as well. So if I run tkn pipeline run list, you can see there are two pipeline runs are there, and it will pick up the latest one. So in the namespace, I haven't exported the name of my project. So this is default init. And if I run this, so these are the logs of all those particular task runs in the pipeline. And we can describe this as well to see what are the results are there. So in the results, as you can see, this is the image URL which came up at the end, the digest, the change kit URL and commit, from which particular commit this pipeline was triggered, and these are the results. So all those things are there. And then extracting the image digest, and also we executed this command in the previous video as well. So basically we are just getting a complete image URL and digest with the help of this command. And then comes the Cosign part. So basically those SBOM which are for this particular image can be like verified with the help of Cosign. So I'm on Mac OS, so I can use Cosign. And for the Linux part as well, you can get it from the latest Git repository as well. So I have already installed the Cosign, and in order for using Cosign to check the pushed images, we definitely need to be authenticated to that registry, and Cosign looks for the credential on this particular path. So what I can do right now, I'm already having my authentication and basically the secret or token, we can say, for qa.io registry account at this particular path. So I can just paste it here in this directory. Okay, and now what I can do, I can run this command like cosign download SBOM. So it will download that SBOM for the image URL and digest. And with this particular utility, it can show the first 60 lines of it. So yeah, so image URL and all these variables are already there, exported, and I can run this command directly. So in this particular Konflux build and installation, it is using deprecated approach for the SBOM and attachments. With the newest approach, it is not present right now, but you can try that out as well as per the official documentation. So if you see, this is the SBOM we downloaded, and it is showing the required details, like the image, the algorithm it used, and all. So all these things are just for the security part. So yeah, and this was the option B I provided. So this is the latest approach where you download the attestation instead of the SBOM. So this will not work since we were with the older approach. So if I even run this command, it will not print any output as far as I know. Yeah, so yeah. And then we can verify the image signature as well from the Tekton Chains, because this particular image signatures were used to sign the image and all. So if I run this command, so basically we are just extracting the public key from this particular secret. And after that, we can just verify the particular image with that public key, whether it is really signed by the private key pair of that public key or not. If that image was signed by a different key or any other key, then we will not be getting this kind of output. We will get some error basically. Right. And yeah, so like these warnings and all are expected right now because this is a very controlled environment, we can say, and not actually using the authentic keys. Because if you see in this command, we use this particular flag, insecure ignore tlog. So I have provided the explanation here. So basically like Tekton Chains science images using clusters on key pair, like stored in signing secrets and all. So like that's why we are using those. Otherwise the default cosign command, which verifies your image and all, it uses the actual public key, which is like the signature which is stored on this particular URL. So that's why I said this is a very controlled environment, we can say, self-hosted Conflux and all. So we are just testing out the things. And then this is the verify attestation command. So like we can give it a try. So yeah, so as you can see, all this output we got. So it only works if you use the correct public key that that will be applicable for the image. Like basically the private key pair of that public key must have signed and pushed the image. So that's how the things work. Otherwise, we will not get any output. So this is the actual data that can be verified, like how actually image was built, what tasks were run, what exact things were there. So that's how the supply chain security is maintained. And yeah, if let's say any task have failed during the pipeline run, so you can troubleshoot those things with the help of these commands. So yeah, and those build definitions, like whatever the scan was performed and all these task runs were performed. So these are coming up from the pipelines definitely. So in this reference guide, I have provided this hyperlink for the official Conflux repo where multiple pipeline CMLs are provided, and you can go through from them to better understand what tasks are there, what other customizations are there, and all. So yeah, that was it for this particular video. Thanks a lot, everyone.